To maintain your physical structure, to simply exist from one second to the next, the body must constantly destroy its own material. It is a continuous cycle. Anabolism builds your structure up, while catabolism tears it back down. This process is powered by the physical breakdown of glucose from the food you eat. Without this never-ending churn of matter, biological decay begins immediately. A single molecule of glucose holds 688 kilocalories of potential energy within its chemical bonds. Releasing that massive amount of stored energy all at once in the open air creates a sudden, violent thermal reaction. You consume hundreds of grams of carbohydrates daily, yet your internal temperature remains stable and controlled. The body manages this energy through a mechanism that functions differently than simple external combustion. This diagram presents a common misunderstanding, that we inhale oxygen specifically to mix it with carbon and exhale the resulting carbon dioxide. Carbon dioxide is actually produced deep inside your tissues without any oxygen present. Enzymes remove carboxyl groups from food, leaving CO2 as a byproduct of digestion. Oxygen waits at the end of the cellular assembly line. Its role is to capture waste hydrogen and loose electrons that would otherwise damage the cell. By binding with these particles, oxygen converts them into pure water. Oxygen isn't used to produce carbon dioxide, it is used to produce water. Since survival depends on oxygen reaching the end of that assembly line, the body uses hemoglobin as a dedicated transport vehicle. This technical diagram shows how hemoglobin interacts with different gases. Carbon monoxide, or CO, binds to hemoglobin more effectively than oxygen does. At a concentration of just 1% in the air, carbon monoxide hijacks 95% of the body's hemoglobin supply. This takeover disables the blood's transport fleet, suffocating cells from the inside even if oxygen is still present in the room. The solution to the 688 kilocalorie problem is the Krebs cycle, the central hub of aerobic respiration. Instead of an explosion, this cycle is a controlled enzymatic dismantling of the glucose molecule. This aerobic process yields 38 to 39 molecules of ATP, the primary energy currency of the cell. This results in a 55% energy efficiency rate. Without oxygen, the body switches to an anaerobic backup plan, yielding only 3 ATP from the same glucose. Most energy here is lost as heat, which explains why brewing vats of yeast naturally warm up during fermentation. The Krebs cycle is the dividing line between efficient energy capture and rapid heat loss. If the body runs out of carbohydrates, the brain still requires a continuous supply of glucose to function. To maintain this supply, the body begins breaking down its own muscle tissue into amino acids. These amino acids travel to the liver, where they are reassembled into brand new glucose molecules. The metabolic system is flexible enough to liquidate its own architecture to preserve the central nervous system. Metabolism demonstrates that survival is a matter of chemical precision rather than brute force. The microscopic process of dismantling sugar molecules and neutralizing waste electrons happens inside every cell every single second. Every breath and every calorie is integrated into a system that has maintained this specific chemical balance for billions of years.